Hi everyone, my name is Saki Omomo. I'm a master student at the University of Tsukuba. My study theme is as shown in the slide. There is numerous research about the effects of sunning to the forest environment, but the impact of sunning on groundwater recharge, which is considered to be particularly complex, is still unclear, and many studies investigating groundwater recharge use suction-less meters to collect samples. That suction-less meters collect unsaturated water that is affected by evaporation and plant uptake. Are suction-less meters really capturing the water that is recharging groundwater? The objective of this study is to reveal the water recharging groundwater by sampling soil water using suction-less meter and retention-less meter, and discuss effective methods for capturing the water recharging groundwater. Moreover, the effect of vegetation distribution on soil water was also investigated by comparing between four sections with different vegetation distribution. The effect of sunning on groundwater recharge mechanisms and groundwater recharge rate was also examined in this study. The study site is Mount Kasawa in Tochigi Prefecture, Japan, where we set up a survey plot in cedar forest and cypress forest. What kind of water is collected by the retention-less meter and suction-less meter? The water collected by the retention-less meter shows relationship with sulfur, while the water collected by the retention-less meter doesn't show a clear relationship with sulfur, indicating that the water collected by the retention-less meter likely be preferential flow. When does preferential flow occur? This figure can be seen that the collection amount of the retention-less meter installed at 30 cm likely have the relationship with the maximum 3-hour rainfall. The maximum 3-hour rainfall at the time when vertical axis is 0 in the approximate curve was set as the threshold for the occurrence of the preferential flow. The threshold value was the largest for section O, 19.38 mm. With this as the threshold for the entire study plot, the sampling period was classified into heavy rainfall and light rainfall. The delta 18 oxygen value at 80 cm is closer to the value of the preferential flow at 30 cm during heavy rain than during light rain. We compared the depth distribution of delta 18 oxygen in open canopy and closed canopy during heavy rainfall, assuming that the soil water at 80 cm is the water recharging groundwater. The water recharging groundwater is isotopically heavier in the open canopy than the closed canopy. This suggests that the water recharging groundwater becomes isotopically heavier after thinning. This study shows that soil water should be sampled using retention-less meters to discuss the water recharging groundwater, and that the water that recharges groundwater after thinning is isotopically heavier than before thinning. That's all. Thank you very much for your attention.